I'm just going to jump into this review. I actually recorded it once and I had a glitch in my video. Actually, a bunch of my videos had a glitch because of a bad cable, and it took about an hour, so that's my best guess. This will be an hour. The first three problems really don't require any algebra. They give us equations, and they ask us whether this equation is a function or not, or more specifically, is y defined as a function of x? And there's a hint on this that says solve the equation for y, sketch a graph using your calculator, and then apply the vertical line test. So for these problems, if when I sketch a graph, the graph fails the vertical line test, I'm going to say the graph's not a function. And if you remember from earlier in this chapter, a graph fails the vertical line test if it's possible to draw a vertical line to touch the graph of that equation in more than one place. This would be not a function, or y is not defined as a function of x, and I'll probably just say not a function because this fails the vertical line test. And if a graph turned out to be something like this, this will be is a function, or y is defined as a function of x, because in this version of the graph, no matter what place I draw a vertical line through, it only touches the graph once. So for each one of these, my answer is going to be either is a function or it's not a function. And I'm just going to sketch a graph. Two of the three, I can sketch a graph without rewriting the equation because they're already solved for y. Problem 2, when I go to do it, I'll have to do some algebra before I graph it on my calculator. So I'll jump into number 1. I'm going to graph the function y equals x minus 3 squared plus 4. I'm going to do zoom standard. I already know what this graph is going to look like, but just in case I'm the only one that knows, I'll graph it for you. So this is just a generic parabola, and I'd certainly say that this graph passes a vertical line test because there's no place I can draw a vertical line through the graph to touch the graph in more than one place. So my answer for number 1, I could either say this is a function, or I could just write the word function down, or I could say y is a function of x. And I almost never choose the longer version of the answer. So on the test, if you write function or is a function, that would probably be what I expect. For problem 2, I can't graph it immediately because it's not solved for y. It has y squared equals to x plus 4. And in order to graph on my calculator, an equation needs to be solved for y. So I'm going to solve the equation in number 2 for y. And in order to solve this equation for y, I have to square root both sides. And when I square root the left side, the square root cancels the square. When I square root the right side, I have to introduce a plus or minus. Anytime a problem has a square and I'm solving by square roots, I have to introduce a plus or minus when I'm doing that solution to get kind of both the solutions. When I go to graph this, I'm going to have to enter one function for the plus version of this and another function for the minus version. And when I do that, I'm going to get a non-function. So let me just graph this real quick so you can see that this isn't a function, or y isn't a function of x, just by entering the square root of x plus 4 and then the negative square root of x plus 4. And now when I graph this, I get kind of a parabola on its side. And this is clearly going to fail the vertical line test because I can draw a vertical line to touch the graph in more than one place. So we'll say that for number 2, my answer for number 2 is I can say either this is not a function or y is not defined as a function of x. And just because it's shorter and probably more common to say, I'm just going to write not a function. And the last one, problem 3, because it's already solved for y, I can jump straight into my sketching and clear out the function that's in there already and do y equals second square root of x minus 1, and then just graph it. And this is kind of a half parabola on its side. The graph looks something like this, and this graph is going to pass the vertical line test. There isn't a place I can draw a vertical line to touch the graph in more than one place. So for this one, we can say it is a function. We could just write the word function, or we can say y is a function of x. Probably the easiest thing to write is just to say this is a function, If you want more grammar than that, you can say this is a function, or you could use the words y as a function of x. The next few problems give us graphs, and they ask us to find the domain and the range of the graph. There's kind of, well, maybe 3 types of problems. Problems 4, 5, and 6 all have a different trick for finding the domain and the range. Problem 4, when it's just a series of disconnected points, if you're asked to find the domain and the range, it would be wrong to connect the points. When you're given a graph and you're asked to find the domain and the range, if the graph is just some scattered points that aren't connected, then the domain is going to be written with set braces. The range is going to be written with set braces. And in the domain, you're going to write the x-coordinate of every x point in whatever order you care to. So the x-coordinates are 3, 4, 5, and 7. My domain is going to have 3, 4, 5, and 7 in it. The range is going to have the y-coordinates of the points. There's -1, 2, 2, and 6. So I could write -1, 2, 2, and 6. But it would be better for my answer to number 4 if I only wrote the 2 once, because it's not necessary to write it twice. If it occurs twice, I can still just write it once for my range. So the best answer for problem 4 would have the domain with those 4 numbers, the range with these 3 numbers, and when the points are just scattered, it doesn't really matter the order that you write the numbers in. In problem 5, to find the domain and the range, I'm going to use interval notation. And the nice thing about problem 5 is both edges of the graph are marked with a point. So this is the kind of graph that doesn't need to be extended. To find the domain, I'm going to take the x-coordinate of the far left point and the x-coordinate of the far right point and write them on the x-axis, kind of above or next to the points. And the domain is I read in terms of x's, it's the x-coordinate of the most left point followed by the x-coordinate of the most right point. And the domain in this case is going to have square brackets because both of those points are on the graph that's given. For the range, I need to identify the bottom point and the top point. The bottom point for this graph is the point 0, -5. I'm going to write its y-coordinate on the y-axis. And the top point for this graph is the point 3, 4. I'm going to write its y-coordinate on the y-axis. And for range, I'd read bottom to top. And my range for this is going to be -5 to 4. Again, it's going to be double square brackets because each of the points is physically on the graph, so I don't get any round brackets. Generally, you only get round brackets on infinities and where there's breaks in the graph when you go to write the domain and the range in interval notation. The last one of these problems that ask me to find the domain and the range, number 6, the left-hand edge is labeled, but the right-hand edge is labeled, but the left-hand isn't. This graph needs to be extended, and it's going to extend forever to the left and down. Eventually, pretty quickly, it's going to make it to the far left edge of the x-axis, and not so eventually, but after a while, it's eventually going to make it down to the bottom of the y-axis. So this graph needed to have the left half extended because the left half wasn't marked with a period. The right half didn't need to be extended because the right edge of the graph was marked with a point. So now when I go to do the domain, I'm going to put on the x-axis the x-coordinate of this point, which is the right edge of the point. And for the domain, I read from left to right and x-coordinates. So the domain for this graph, the x-coordinate of the far left edge of this graph is -infinity. Infinities always get round brackets. The right edge of this graph has an x-coordinate of 0, and points on the graph get square brackets. For the range, I read from bottom to top. The bottom of this graph has a y-coordinate of -infinity, and the top of this graph has a y-coordinate of 2. So for the range, I read from bottom to top on the y-axis. The graph eventually goes down to the bottom of the y-axis, which has a y-coordinate of -infinity. It stops here, which is the top of this graph, which has a y-coordinate of 2. When I go to write the range, I'm going to do it in interval notation. The bottom of the graph has a y-coordinate of negative infinity. The top coordinate of the graph has a y-coordinate of 2. I read bottom to top for the ranges and left to right for the domains. If you write the numbers backwards, I'll just probably write them in the right direction. It's technically wrong, and you might get a teacher in some other class that will take points off if you do the range backwards. So range is always bottom y to top y. 7 through 9 give us equations, and they ask us to find the domain and write your answer in interval notation. And there's 3 separate techniques because there's 3 kinds of problems. There's a fraction, a square root, and a polynomial. To find the domain of a fraction, you ignore the numerator. So as I go to do problem 7, if I want to find the domain of that function, I'm going to ignore the numerator of x minus 4. The algebra that I'm going to need to do is I'm going to solve the denominator equal to 0. And then I'm going to do some work to figure out how to write my domain in interval notation. So I ignore the numerator to find the domain of a fraction. I solve the denominator equal to 0. In this case, the denominator has a square in it, so when I set it equal to 0, I need to solve by factoring. Once I have it factored, I split the factors up, set each of the factors equal to 0, and I'm going to get x equal to negative 7 and x equal to 1 for numbers that belong in the domain, but it's not the domain itself. When you're finding the domain of a fraction, once you get the numbers that make the denominator equal to 0, you take those numbers and you put them on a number line that also has negative and positive infinity. So I did the algebra to find the numbers to exclude from the domain, and to write my domain in interval notation, I put those numbers on a number line along with negative and positive infinity, and then I make intervals. I always get one more interval than numbers that I put on the number line from this step. I had 2 numbers on the number line that weren't infinities. I'm going to get 3 intervals, and the intervals are going to be all round parentheses, and that will exclude the numbers negative 7 and 1 from the domain. This is essentially my domain. It's these 3 intervals, and I'm going to separate these 3 intervals with union symbols when I go to write my answer. So for fractions, you usually get round parentheses for every part of your domain. So I'm going to say my domain is the interval from negative infinity to negative 7, union the interval from negative 7 to 1, union the interval from 1 to infinity. That would be the answer to number 7. Each one of these 3 pieces has completely different algebra. There's no denominator to set equal to 0 in number 8 or number 9. So that algebra wouldn't even make sense to do. To find the domain of a square root, you just set the radicand greater than or equal to 0. So the algebra to find the domain of a square root is you take the radicand, and the radicand, the numbers and letters under the radical, and you set it greater than or equal to 0. This is going to give me x plus 5 is greater than or equal to 0 when I set the radicand greater than or equal to 0. And if I minus 5 from both sides, I get x is greater than or equal to negative 5. This is technically the domain. If I want to show this on a number line, the interval from the numbers that are greater than or equal to negative 5 are any number from negative 5 off to infinity. This would be a picture of the domain. The algebra for the domain of a fraction gives you the numbers that get excluded from the domain. The algebra for the domain of a square root actually gives you the domain in inequality notation. I need to transfer that into interval notation, and my domain is going to be any number that's negative 5 or bigger, and in interval notation that would represent the interval from negative 5 to infinity. If you plug a number less than negative 5, like negative 6 into this, you'll get an I. Any number negative 5 or bigger, if you plug it in, you'll get either an ugly decimal or a nice integer. So fraction domains and square root domains, you find it completely differently, and polynomial domains you find differently yet. So there's 3 kinds of algebraic domains that we did in this section, and fractions, you set the denominator equal to 0, create number lines, create intervals. Square roots, you set the radicand greater than or equal to 0, you do the algebra, and that gives you the domain. For polynomials, there's no algebra for the domain. And if you do any algebra, the algebra is likely to find the x-intercept, and it's going to have nothing to do with the domain. The algebra, there's no algebra to find the domain of any polynomial. All polynomials have domains of negative to positive infinity because the graphs don't have any breaks or starting or ending points. Let me show you really quickly how these domains are kind of correct on my calculator. So I'll show you by graphing why this domain is every number except negative 7 and 1 by just graphing the function x minus 4 divided by parentheses x squared plus 6x minus 7. When I graph this, this is at negative 7. The graph has a break at negative 7 and then again at 1. So the graph exists from all the way from negative infinity to the negative 7. Then it exists between negative 7 and 1, doesn't exist at 1. Then it exists from 1 to infinity, even though you can't see the graph here because it gets so close to the x-axis. So fractions, because they have breaks in their graphs, their domains are segmented, and with round parentheses because the graph doesn't exist at those breaks generally. The next one, the square root of x plus 5, if I graphed it to show you its domain, that graph is going to start at negative 5 and go off to infinity. So it only exists from x equal to negative 5 off to infinity. It doesn't exist to the left of negative 5. So that part it's not included in the domain. And I don't have any breaks because the graph isn't segmented. It's just one continuous graph. But it's not negative to positive infinity because it doesn't exist everywhere. The last equation, y equals 2x minus 6, if I graphed it, it doesn't have the breaks that the fraction has, and it doesn't have a starting or stopping point. It goes on forever. It goes off the screen, up and forever, and down and forever. And it exists everywhere without any breaks. That's why it has a domain of negative to positive infinity. All right. Don't know if I'm going a lot slower than last time or not. 10 through 13 just want us to get used to function notation. 10 wants me to find f minus g of x, and that's just going to be f of x minus g of x. To do f minus g of x, I'm going to the right of an equal sign, create two parentheses with a minus sign between the parentheses. The minus sign is that minus sign. In the first parentheses, I'm going to put what f of x is equal to, which is x squared plus 3x minus 4. And in the second parentheses, I'm going to put what g of x is equal to, which is 7x minus 7. Now I'm going to just simplify this to get my answer. So f minus g of x is going to be whatever this simplifies to. The first parentheses I put in, I could just drop without doing any altering of the x squared plus 3x minus 4. The second parentheses, this minus is going to attach to the 7x and make it a minus 7x. And it's going to flip the sign of that negative 7 and make it a positive 7. Now I need to combine like terms. The like terms I'm going to combine are the 3x and the minus 7x and the minus 4 and the plus 7. When I go to get my next line, I'm going to bring down the x squared because the x squared has nothing to combine with. And I'm going to figure out what 3x minus 7x is, and I'm going to figure out what minus 4 plus 7 is. Those are the like terms that need to be combined. 3x minus 7x is negative 4x, and minus 4 plus 7 is positive 3. I would consider this an okay answer. If you gave this to me on a test, I'd give you full credit. But because it factors, a better answer would be the factored version of this. And so my answer that I'd probably write in my solutions manual would be this factored, and this factors into x minus 1 times x minus 3. If your factoring skills are kind of not what they should be, come visit me in my office. I can teach you, reteach you factoring. If you're good at it at one point, I can teach it to you pretty quick. If you're never good at it, then we'll have to spend a decent amount of time to get you, to be good at factoring. Problem 11 wants me to find f composed with g of x, and that just means to find f of g of x. And to find f of g of x, I need to take both of these x's and change them to g of x, because f of anything, you're going to change the x's to what that anything is. So this is going to be g of x squared plus 3 times g of x minus 4. And now I'm going to change the g of x to 7x minus 7 and get really a horrible problem that I should make an attempt to factor at the very end, but I might not have the desire. So I wrote the problem without the composition notation, and then I figured out that that meant to change each of the x's in the f function to g of x, and now I'm replacing the g of x's with the 7x minus 7. And now I'm going to simplify this. The first simplifying I'm going to do is the 7x minus 7 squared, and I'm going to do that by foiling, writing it as 7x minus 7 times 7x minus 7. So I'm going to get f composed with g of x equals, and I'll do first, 7x times 7x is 49x squared. Outers, 7x times minus 7 is minus 49x. Inners, minus 7 times 7x is minus 49x. And last, minus 7 times minus 7 is plus 49. And then I might as well clear this parentheses by going 3 times 7x is plus 21x. 3 times minus 7 is minus 21. And bring down this minus 4. This is an unsimplified version of the answer. Now I'm going to combine like terms and get something that I should probably attempt to factor, but I'm probably not gonna because the numbers are too big. So this 49x squared I'm going to bring down. And these three terms, minus 49x, minus 49x, and plus 21x, I'm going to combine. And to do that, I'm going to use my calculator. I can't do the x's on my calculator, but I can go minus 49, minus 49, plus 21. And that's going to give me a minus 77x. And then the last numbers I need to combine are positive 49 minus 21 minus 4. So I'm going to go 49 minus 21 minus 4. And that's going to give me a positive 24. I should attempt to factor that, but that's really beyond, anything that I'd ever expect you to factor on a test, because it might take me the better part of 20 minutes to figure out whether that factors or not. I'm going to call this the answer, even if by chance it did factor like the last answer. Since the numbers are so big, I'm not going to, expect you to factor that. And on these working with functions, adding, subtracting, multiplying, dividing functions, if you miss the factoring at the end, I'll write it in, but not penalize you for it. 12 and 13 are similar, but they have numbers in the parentheses. 12 wants me to find f plus g of 5. To do that, I'm going to first find f plus g of x, and then I'm going to change the x to 5. So f plus g of x is f of x plus g of x, which means that's equal to x squared plus 3x minus 4 plus 7x minus 7. Should probably put those in parentheses, although it's not really necessary when you're adding functions. So this is f plus g of x. I can simplify now, or I can simplify when I get a little deeper into the problem. In this problem, I have to plug 5 in for x, and I can simplify with 5s better than I can with x's. So before I simplify, in this problem, I'm allowed to change the x to 5. So I'm going to change the x to 5 and then simplify, because my answer is what f plus g of 5 is. So I'll take what f plus g of x is and change my x's to 5, and now I'll just simplify. Let me be super lazy and do this on a calculator. So this is going to be parentheses, 5 squared plus 3 parentheses 5 minus 4 parentheses plus parentheses 7 parentheses 5 minus 7 parentheses. My answer is going to be 64. That'd be kind of nice. Wrote down what you need to do to get the answer and then do the work on your calculator. That's a lot safer than doing it by hand. If I did it by hand, this parentheses would be 25 plus 15 minus 4, and this parentheses would be 35 minus 7. This is 25 plus 15 is 40, minus 4 is 36. Once I get it down to one number, I drop the parentheses, and this is 35 minus 7 is 28, and 36 plus 28 is 64. You don't need to show that much algebra if you don't care to. Just had a hiccup in the video. Hopefully where I had the hiccup, it didn't mess up. So first I found f plus g of x, which was f of x plus g of x. I didn't even simplify it. I put the problem back into play, changed the x's to 5s, and did all this work on my calculator to get the 64. Then I followed it up doing it by hand. You're welcome just to do it on the calculator. But on the test, if you make a mistake on your calculator, if you would have had this line and then that line, and you had a mistake because you'd pressed the button wrong, you'd lose a -1. So you wouldn't get dinged very hard for a calculator error, as long as you showed me what you have to enter on your calculator. 13 wants me to find g composed with f of 4. So the first thing I'm going to find is g composed with f of x. And g composed with f of x is g of f of x. And that I do by changing in the g function. I change the x to f of x. So that's going to be 7 times f of x minus 7. Just changing that x in the g function to f of x. And that's going to be 7 times x squared plus 3x minus 4 minus 7, changing that f of x to what it's equal to. So now I have something I can use to find g composed with f of 4. To find g composed with f of 4, I'm just going to take the 4 and plug it into what g composed with f of x is. So I'm going to go 7 times 4 squared plus 3 times 4 minus 4 minus 7. You could do that on my calculator. Sometimes my calculator is hard to see, but I'd go 7 parentheses 4 squared plus 3 parentheses 4 minus 4 parentheses minus 7. And my answer would be g composed with f of 4 equals 161. That's how I kind of prefer you to, this is what I prefer you to show for this problem. If you want to do this by hand, this would be 7 times 16 plus 12 minus 4 minus 7. This would be 7 times 24 minus 7. This is going to be 168 minus 7, which is 161. So this junk in here, I kind of even prefer if you didn't show that. It's kind of pointless to show it if your calculator would do it. If all you had was these 3 lines and this line, even if you had a mistake on this number, if that line's correct, then you're not going to lose but 1 point. I always put 14 on the test specifically because right in the first week or 2 of a calculus class, you have to do difference quotients. So for this problem, I need to, in this difference quotient, I need to replace each bit of function notation. The function notation is f of x plus h and f of x. To find a difference quotient, I need to replace the function notation with what it's equal to. Well, f of x, I can be replaced with x squared plus 5x plus 2. I need to figure out what I can change f of x plus h to, and that's easy to do. To figure out what f of x plus h can be replaced with, I'm going to change each x in the f function to x plus h and get x plus h squared plus 5 times x plus h plus 2. That's going to be x plus h times x plus h plus 5 times x plus h plus 2. That's going to be something now that I'm going to FOIL. I'll do first x times x is x squared. Outers, x times h is xh, and I'm going to write plus 1xh. Inners are h times x, and I'm going to write plus 1xh for that as well. Last are h times h, which is plus h squared. Done with the foiling, now I'm going to clear this parentheses by going 5 times x and 5 times h. That's going to give me plus 5x and plus 5h, and then the plus 5h, and then the plus 2. I'm going to combine like terms. And there's not much in the way of like terms. Those like terms can be combined. This is going to give me x squared plus 2xh plus h squared plus 5x plus 5h plus 2. And this whole mess is what I'm going to change f of x plus h to. So for my answer, I need a lot of room here. So I'm going to say this equals, and this doesn't need to go into parentheses, but this does, equals x squared plus 2xh plus h squared plus 5x plus 5h plus 2 minus, and then generally I'd have minus in a parentheses, f of x, which is x squared plus 5x plus 2. So this is what I should write after the minus sign, but I'm going to write it above and clear the parentheses just so my work doesn't get too long. So the minus this, minus f of x is that, and this is going to simplify to minus x squared minus 5x and minus 2, because this minus is going to flip all the signs in the parentheses. So this is the numerator of my difference quotient. The denominator of my difference quotient is just h. Now lots of things are going to cancel. This x squared cancels with that minus x squared. This 5x cancels with that minus 5x. And this positive 2 cancels with that negative 2. So what I'm left with in the numerator is 2xh plus h squared plus 5h all over h. I'm almost at my answer. In the numerator now, I'm going to each term has an x. I'm going to pull out an x from each term as a common factor. When I take an h away from the 2xh, I'm left with 2x. When I take an h away from the h squared, I'm left with h. When I take an h away from the 5h, I'm left with 5. Now I'm going to cancel the h's. The fraction's gone. What's left in the numerator is my answer, and I don't need the parentheses anymore. My answer is the difference quotient, f of x plus h minus f of x over h equals to 2x plus h plus 5, and you'll do that a ton if you take regular calculus or brief calculus, so it's real important to do. 15 through 20 don't have any algebra. They want me to look at a graph and identify features. For 15, it wants me to identify the x-intercepts of this graph. The x-intercepts are any point that's on the x-axis that's part of the graph. That's going to be the point negative 4, 0, and positive 0, 0. The y-intercept is going to be any point on the y-axis, and the only point on the y-axis is that 0, 0. That 0, 0 is on both the x and the y-axis, so it's going to be both an x and a y-intercept. It's the only point on the y-axis, so the y-intercept is only the point 0, 0. Next, I'm asked to find for what values of x is h of x equal to negative 4. This negative 4, because it's to the right of an equal sign, represents a y value. And in problem 17, I'm just asked to find any point that has y equal negative 4 and identify its x coordinate. The only point that has a y coordinate of negative 4 in this graph is that point negative 2, negative 4. The answer for problem 17 is going to be x equal to negative 2. Problem 18 asks me to find h of negative 4. Because the negative 4 is in a parentheses, the negative 4 represents x equal to negative 4. So when you're dealing with function notation, numbers to the right of an equal sign are y values, numbers in a parentheses are x values. The negative 4 in this problem represents that x equal to negative 4. And when I go to write my answer, I want the y coordinate of this point. For my answer, I can just write y equal to 0, or I can write h of negative 4 equal to 0, or I can write 0. So my answer, there's lots of choices here. My answer to part B, if you just wrote the number 0 down, that's completely fine. If you wrote y equal to 0 down, that's equally fine. And if you wrote the problem, h of negative 4, and wrote equal to 0, that's also fine. They're all equally fine. The bottom one's probably the best answer. To do the domain for this in problem 19, the left edge is marked with a period, so I don't need to extend that half. The right edge isn't marked with a period, so I'm going to extend this up and to the right forever. This graph very slowly goes to the right. Eventually it makes it to the far right edge of the x-axis. When I go to do the domain, I identify the left edge, and the left edge is this point negative 4, 0. I'll write its x coordinate on the x-axis. And the right edge I can't see because it goes off the screen, but at the right edge is at the far right edge of the x-axis, which has a coordinate of infinity. For the domain of this, I'm going to say its domain is -4 to positive infinity. For the range, I need to pick off the bottom, and the bottom of this graph is this point -2, -4, and its y-coordinate I'm going to write on the y-axis, which is -4, and the top of this graph goes to the top of the y-axis, which has a y-coordinate of infinity. When I go to write the range, I read from bottom to top, and the bottom of this graph has a y-coordinate of -4. It's a point on the graph, so it gets a square bracket. The top of this graph has a y-coordinate of infinity. It's not a point on the graph, so it gets a round bracket. The next couple problems want me to find intervals where the graphs are increasing, decreasing, and maxes and minimums. And to do these, I'm going to ignore a lot of junk. I'm going to ignore x-intercepts. I'm going to ignore y-intercepts. And I'm just going to find turning points and their x-coordinates. So I'm going to ignore the y-coordinates of any of the turning points. So on my x-axis, I'm going to write -3, which is the x-coordinate of that maximum point, and -1, which is the x-coordinate of that minimum point. And I'm going to also put negative and positive infinity. And I'm going to create intervals just like I did for the domain of a fraction. The intervals I'm going to create are -infinity to -3, -3 to -1, all round brackets, and -1 to infinity. In each interval, I need to determine if the graph is increasing or decreasing. The interval of the portion of the graph that corresponds to the first interval, as I move from left to right, the graph is getting higher. So in that interval, the graph is increasing. I'll put a little up arrow to represent increasing, and I'll put that in my answer to part A. That's where the graph is, an interval where the graph is increasing. In the next interval, that corresponds to -3 to -1, the graph as I move from left to right is going down. And in that interval, the graph is decreasing as I move from left to right because it's getting lower as I move from left to right, and that implies decreasing. The portion of the graph that I can see that corresponds to -1 to infinity is this portion of the graph. As I move from left to right, the graph is going up. So this is also another increasing interval. This was a decreasing interval, and that interval goes in the answer to part A. When you have multiple intervals, you separate them with union signs. The 2 points that I kind of destroyed is this point -3, -8, and this point -1, -12. The point -3, -8, because it's at the top of a little peak, I would think this is a maximum point. And the point -1, -12, because it's at in a bottom in a little valley, this is going to be a minimum point. And when I go to answer the questions C, D, E, and F, C wants me to find the values of x where the function has a local maximum. That point -3, -8 is a local maximum point. The value of x there is x equal to -3. Part D wants the local maximum value. That's the y-coordinate of the maximum point. I'm going to write y equal to -8. E wants the value of x where the function has a local minimum. That's going to be the x-coordinate of that point, which is x equal to -1. And part F wants the local minimum value. The local minimum value is the y value that corresponds to that x. In this case, it's going to be y equal to -12. We get another one of these increasing and decreasing problems right away here. And I don't know if it's easier or harder. So to do the increasing and decreasing part, I don't worry about x-intercepts. I simply look for turning points. The only turning point in this graph has an x-coordinate of 3. I'm going to put it on my x-axis with positive and negative infinity and create intervals. The intervals for increasing and decreasing in this one are -infinity to 3 and +3 to infinity. The portion of the graph that corresponds to -infinity to 3 interval is this portion, and as I move from left to right, in this portion the graph is getting higher as I move from left to right, so that first interval will say the graph is increasing. The next interval, 3 to infinity, corresponds to this part of the graph, and for this part of the graph, As I move from left to right, the graph is getting lower. So we'll say it's decreasing in that interval. The turning point here is a maximum point because it's at the top of the graph. And tops are maximums, bottoms are minimums. So when I go to answer part C, find the value of x where the function has a local maximum, it has a maximum at that point, which has an x coordinate of 3. It only asks for the x value in part 3, so I'm going to say x equal to 3. Part D wants the local maximum value, which is just the y coordinate of that maximum point, which is y equal to 4. This graph only has one hump, so it can't have both a maximum and a minimum value. It doesn't have a low point. It goes down to the bottom of the y-axis, but it would need to do something like this. It would need to turn back up and get a little valley to have a minimum point. This graph doesn't have a little valley, so it doesn't have a minimum point. The values of x where the function has a local minimum is none, and there's no local minimum value either. All right. 23 wants me to find the average rate of change. The average rate of change is just the slope of the line that connects 2 points. So the average rate of change, the formula is just y2 minus y1 over x2 minus x1. It's just slope. And in this problem, the two numbers that are given are the x1s and the y1s. So x1 is going to equal to 4, and it's the x1 and x2, and x2 is going to equal to 5. In order to get the y1 and the y2, I'm going to need to plug those numbers into the function. So to get y1, I'm going to plug 4 in for x and go f of 4 equals 3 times 4 minus 2 squared minus 4. And I'll do that on my calculator, just going parentheses, parentheses 3, parentheses 4, minus 2, parentheses squared, minus 4. That gives me 96 for the y1. To get the y2, I'm going to find f of 5. F of 5 is going to be parentheses 3 times 5 minus 2 squared minus 4. So I'm going to go parentheses 3 times 5 minus 2 squared minus 4. y2 is going to be 165. What I've done right here is created 2 points. I've created the point 496, which is the x1, y1, and 5, 165, which is the x2, y2. 12, 10, 100, that's right. 15, yeah, that's right. Now I'm going to find the average rate of change. I'll abbreviate this, average rate of, and do a triangle for change. It's going to be y2, which is 165, minus y1, which is 96, over x2, which is 5, minus x1, which is 4. I think this comes out to be 69 over 1. The 1 I know for sure. Let me do 165 minus 96. That is 69 over 1, which is 69. So my answer to 23, the average rate of change equals to 69. If you just wrote the number 69, that would be fine. Yuck. All right, 25 says sketch a graph of f of x equal to x squared. We did this a ton, so let me just make the generic table to do this graph. So I'm going to put in my x column to graph the function f of x equals x squared, -2, -1, 0, 1, and 2. And in my y column, which is f of x, I'm going to square each of these. So the first y is going to be -2 squared, which is positive 4. The second y is going to be -1 squared, which is positive 1. The third y is 0 squared, which is 0. The fourth y is 1 squared, which is 1. That's just changing each of those x's to the number. And then the last is 2 squared, which is 4. So I'm going to plot these points. So -2, 4, -1, 1, oh gosh, 0, 0. I don't like this window. 1, 1, and 2, 4. This window makes this graph look so fat, and it's not really that fat. I had to play with the numbers on the y-axis. My y-axis are incremented by 4, and that just makes this graph look unusually fat, but that seems good enough for it. Part B wants me to find 4 times f of x. Well, if f of x is equal to x squared, because that 4 is not in a parentheses, the 4 is just going to go in front of the x squared. The answer to part B is 4f of x equals 4 times x squared. Now I'm going to make a table of values and sketch a graph. And because the number that I'm multiplying by is not in the parentheses, I can use the same x value, should I say, of -2, -1, 0, 1, and 2. Don't feel like doing those y's in my head, so I'm going to use my calculator to get the y's. I'm going to graph the function y equals 4x squared and just peek at my table going second table. Oh my gosh, I don't know why I'm at 100 and something, but now I'm going to have to go way back to get down to that -2. Sorry about that. Lovely waste of time. There's got to be a quicker way to get there, but I don't know how to do it other than arrowing. There's somebody knows that you can tell me so I don't have to do this again. Finally got here. So next to -2 I get 16. Next to -1 I get 4. Next to 0 I get 0. Next to 1 I get 4. And next to 2 I get 16. So I'm going to plot those points. The point -2, 16. The point -1, 4. The point 0, 0. The point 1, 4. And the point 2, 16. And that's the graph of 4f of x. The original blue graph was the graph of just f of x equals to x squared. Done with part C, I made a table. Part B, I found the 4f of x. Part C, I made a table of values and sketched a graph. Now I'm going to describe the transformation. This graph got narrower, so I can say it got narrower, or the other way that we said that is it gets stretched. So either I'm going to use the word it got narrower or skinnier, or you can say the graph got stretched. Those are interchangeably good answers for problem 25. All right. 26 through 30 wants me to create a function that compares to f of x equals x squared, but it's moved. And to move a graph, I should know that f of x minus some number in a parentheses is going to shift the graph right. F of x plus some number in a parentheses is going to shift the graph left. F of x plus a number not in a parentheses is going to move a graph up. F of x minus some number not in a parentheses is going to move a graph down. And f of negative x is going to reflect over the y-axis. Waiting for a break in my video. And negative f of x is going to reflect over the x-axis. So with those in mind, I should be able to do each one of these problems. There's no algebra for these problems. So problem 26, I'm creating a function that compares to f of x that's shifted to the left 4. So this is just going to be f of x plus 4. That plus, to find the function, so that 4 had to be in the parentheses to shift left. To find the function, I'm going to change that x with the parentheses to an x plus 4. When the number's in the parentheses that you're changing, then when you rewrite the problem, that has to go in a parentheses. For part 27, to shift it right, I need an f of x minus a number. In this case, it's going to be f of x minus 4. And the answer to this is going to be x minus 4 quantity squared, because that will shift the graph to the right, and it'll shift the graph of x squared to the right. For 28, a function that's going to go right 5 and up 3. To go right 5, I'd need f of x minus 5 in a parentheses. To go up 3, I'd need a plus 3 after. To find the function, the x minus 5 needs to go in a parentheses with a square. And the plus 3 goes after the function. For 28, to go left 2, I need a plus in a parentheses to go left. To go down, I need a minus after the function. And relative to f of x equals x squared, the function I'm going to need is x plus 2 quantity squared minus 3. For reflected over the x-axis, that's just negative f of x. So reflecting over the x-axis is negative f of x. And that's just going to be negative x squared, or if you want, you can write negative 1x squared. To reflect over the y-axis, I need f of negative x. Because that negative x is in a parentheses, it needs to go in a parentheses. You could write negative x squared for your answer, or you can simplify that and multiply negative x times negative x and get positive x squared. So for your answer to problem 30, you can write either f of negative x equals negative x squared, or you can write f of negative x equals positive x squared, because when you clear the parentheses, you get a positive x squared. All right, one problem left, so it's taking me about the same amount of time as last time, and it's the word problem. Just made a mistake on problem 31, so I'm going to cut and paste the correct work in. So problem 31 is the only word problem that's going to come on the test. You'll see probably a duplicate of this if you take me for brief calculus, and you could see a duplicate of this if you take any calculus course. So campground owner has 2,000 feet of fencing. He's going to make a rectangular field bordering a river, and that implies that we only have to build 3 sides of the fence. So I'm going to draw the picture. Here's the river. I don't know why it doesn't say we don't need a fence next to the river, but that's supposed to be the case. And this is what we're building. We're going to build 3 sides. 2 of the sides we're going to call W, that stands for width, and 1 we're going to call length. So the L for this is going to be the length of the field that we're building. It's the side parallel to the river. And the W is going to stand for the width. You'd get the same numbers if you switched my W's and L's, and which would be fine. But this is what we've done for all the problems, so I'll be consistent. So now I'm going to come up with an equation for the length by knowing that I'm building 1 length and 2 widths, and they're supposed to use all the fencing that I have, which is 2,000 feet of fencing. And when we did this earlier in the chapter, we would just solve this equation for L to get an equation for the length of the field. I'm not going to write it here, I'll write it over here. The answer that I'm going to get for part A, the equation for the length of the field, is length equals minus 2W plus 2,000. When I did this by hand, or last time my mistake, I wrote 1,000 there, which made everything wrong. Now I'm going to find an equation for the area of the field. Well, this field that we're enclosing is just a rectangle. The side that has the river is still a length, and the side opposite's the length. The sides perpendicular to the river are widths. The area for any rectangle is length times width. For this problem, in order to get something productive done, I'm going to change that length to minus 2W plus 2,000. So I'm going to say area equals minus 2W plus 2,000 times W. And now I'm going to clear the parentheses by going minus 2W times W and get minus 2W squared, and then 2,000 times W, which is plus 2,000 W. That's the answer to part A. So I did minus 2W times W, got minus 2W squared. 2,000 times W is plus 2,000 W. That's the area equation. To find the value of W leading to the maximum area, you can do this by graphing, but it's a lot easier using the formula. So I'm going to use the formula negative b over 2a, which is going to give me the vertex of the parabola that's represented in this equation. And the vertex is the maximum point. It's where the width is the width that gives you the maximum area. And for this formula, the a is going to be the number in front of the square term, which is negative 2. The b is going to be the number in front of the first power term, which is 2,000. And now when I do negative b over 2a and simplify that, I'll get the answer to part C. For negative b, I'm going to put a negative from the formula and 2,000 for the b. For 2a, I'm going to write 2 times negative 2. This is going to be negative 2,000 over negative 4. That comes out to 500. I'm going to squeeze my answer in right here. I'm say the width is 500, and I should put units because these lengths are in feet. I'm going to say the width is 500 feet. To find the length, I'm going to use this formula. Length equals minus 2W plus 2,000. And I'm going to plug 500 in for the W. So I'm going to get length equals minus 2 times 500 plus 2,000. This is minus 1,000 plus 2,000, which is 1,000. And my length I'm going to write as 1,000 feet. And lastly, I need to find the area. The easiest area equation is area equals length times width for this part. And into the area equation, I'm going to put 1,000 feet for the length and 500 feet for the width. I'm going to multiply 1,000 times 500 and get 500,000. So the area is going to be equal 500,000. And then I need units. When you multiply feet by feet, you get square feet. So that would be the best answer for part E. So that's everything on the review. If you can do all the problems on the review, then you should be completely fine for the test. I never try to sneak something on the test that isn't just like something on a review.